So we're going to look today at a way to find the equation of a line if we don't know the y-intercept. If we're given a point and we know a slope, how can we find the equation of the line? Here's what we've done up to this point. If we knew that our line passed through the point 0, 3, for example, and had a slope of negative 3/4, which would be from there down 3/4, we could graph that line and we could come up with its equation pretty easily. We know the y-intercept. The y-intercept is 3, and the slope is negative 3/4. Our equation would be y equals negative 3/4 x plus 3. So we want to keep that in mind. That y equals mx plus b is kind of the gold standard for graphing anything. It's also a good way to write this equation as a function. Remember, we could write f of x equals a little bit more grown-up way of writing y. And really good form to have our line in. So we knew that because we had this point 0, 3, we knew that was the y-intercept. But what if we didn't know the y-intercept and we wanted to find that gold standard, that y equals mx plus b for a line? So we're going to look at that today. So here's an example. What if I told you we had a line that passes through the point negative 9, negative 4 with a slope of 1/3? Well, I don't know the y-intercept, right? I don't know it from the given information. One thing I could do here is I could graph this pretty easily and find out what the y-intercept is. Sometimes I can do that by looking at it. So let's see, negative 9, negative 4 would be right here. So there's that point, and I put it on the graph. Now let me count out the slope. I could count up 1/3, up 1/3, up 1/3, and hey, there's my y-intercept. So one acceptable way to do this, if you happen to have graph paper with you, is to count it out. We can see then that our y-intercept is negative 1, and that would give us the equation of the line y equals, our slope was 1/3, x minus 1. So that's nice and easy if our numbers are small enough and if that line crosses at a nice corner point. Let me show you an example of where it doesn't quite do that. So in this equation, I'm looking for the line that passes through the point 2, 4, and I've labeled that on the graph here, and has a slope of negative 2/3. So from that 2, 4, I would go down 2 and over 1, 2, it's a negative 2/3, up 2 over 1, 2, 3. My line would look like this. And you can see the y-intercept, it's not really an exact corner point. Luckily for us, though, we have a way to find that exact value of the y-intercept. We have a formula here. We have a quick, easy way. We just plug numbers in and come up with our formula. Now, there's two ways we can look at this formula. There's the book way, kind of the more famous way, and then I'm going to transform it for you. It's just going to save you a step. So we use this formula. It's got a name. It's called the point-slope formula. It's easy to remember because we use this formula when we have a point and when we have a slope. We really just plug into this equation, okay? We plug into this formula. Point-slope formula, just to be formal here, it's for looking for the equation of a line that passes through a given point. And that given point in our formula, we're going to call it x1, y1, that has a slope of m. Okay, so that's what we're looking for. The equation looks like two things. Your book and most textbooks are going to refer to it like this. They're going to say y minus y sub 1 equals m times x minus x sub 1. So what happens here is we know the point, we know the x1, and we know the y1, and we know the m, and we're going to fill those into the equation. So we're going to fill in this number, and this number, and we're going to leave the x and the y in the equation. Those will be the xy in our y equals mx plus b. So 3 numbers, 2 variables, we plug them in. Now what we do with that is we will then distribute the m and add that y1 over here, and we come up with the y equals mx plus b. So to me, that's always been a little bit goofy. We distribute and then we add that y1. So I like to give this equation, it's the exact same thing. I just write it a little bit differently. I'm going to write it as y equals m times x minus x1, which is the exact same thing. I'm just going to write plus y1. So I've saved you that step at the end. Instead of adding the y1 at the end, I've rewritten the equation with that plus y1 added in. So what we end up with is our slope-intercept form. We get that y equals mx plus b. So let's go back to that last problem that we had, and we'll see if we can calculate that y-intercept exactly. So here's the equation, our general formula, y equals m times x minus x1 plus y1. And again, we're just going to fill in those three values that we need. We're going to fill in the slope, we're going to fill in the x, and we're going to fill in the y of the point that we were given. All right, so that's going to take us to y equals our slope that we were given, negative 2/3. Again, that just came from the problem, times x minus the x that we were given, that 2, plus that y1, which was the y that we were given, plus 4. Just about done. All I need to do is distribute, combine some like terms, and I'm finished. Y equals negative 2/3. If I distribute, negative 2/3 x. Now that's negative 2/3 times negative 2 would be plus 4/3 plus 4. 4/3 is 1 1/3, so plus 4 should be 5 1/3. So my equation, y equals 2/3 x plus 5 1/3. And let's just check that on the graph up here. 1, 2, 3, 4, 5 1/3. There we go. So I should be able to check this against my graph and know that I got the right answer. Again, this is not many formulas we ask you to memorize in Algebra 1. There's the slope formula and this one, maybe a couple more before the year ends. Write that one down and keep it in mind. Let's do 2 more problems and I'll just have you practice. So I've given you point of negative 5, 2, so our line passes through the point negative 5, 2. 2, 3, 4, 5, up 2. That's this point right here. And I'm saying has a slope of 3/5. Well, again, one way to do that is let's just count it out on the graph. If I have graph paper, let me use it. From that point, again, because we have that constant rate of change anywhere between any 2 points on this line, I can count up 1, 2, 3, and over 1, 2, 3, 4, 5. And look, I have my answer already. There's my y-intercept. I can write that equation. Y equals my slope 3/5 x plus 1, 2, 3, 4, 5. My y-intercept is 5. But let me use the equation. I'll just show you how that works again one more time. I do y equals my slope 3/5 times x minus the x value. Now, because the x value is negative here, I do have to watch the signs. X minus negative 5 plus the y value, and the y value is 2. So that's 3/5 times really x plus 5 plus 2. And now again, I'm just going to distribute and clean it up. 3/5 x, that's y equals 3/5 x. 3/5 times 5 is just plus 3 plus that 2. Gives me same answer I had to begin with, 3/5 x plus 5. So with small, easy numbers, they're really easy to count out. But this is actually a useful formula to take with you in other subjects that you're studying too. So suppose you're in science class and you need to model the behavior of something that's changing at a constant rate. We can use this formula with numbers that are not so nice and clean and easy. So let's do one of those and then we'll stop. So here's a quick little word problem. The temperature of a substance that's been left outside has been falling at a constant rate of 1.75 degrees per hour. After 6 hours, its temperature was 53 degrees. Write an equation that models the temperature y after x hours, and then predict the temperature of the substance after 9.25 hours. So I'm going to just kind of rough sketch this. I've got something left outside, and it's falling at the rate of 1.75 degrees per hour, so it's decreasing. My slope's going to be negative. After 6 hours, the temperature was 53 degrees. So somewhere on this line is the point 6 comma 53. In other words, after 6 hours, it was 53 degrees. We want to write an equation that's going to model that behavior. Well, I don't know the y-intercept. I could keep counting up and over until I hit that point, counting up by 1.75. But I also have this formula that I can use that will help me come up with the equation. So let me do that here. And again, it's y equals the slope. Now my slope is 1.75 degrees, except it's been decreasing, so negative 1.75 times x minus the x value, that would be our 6 hours, plus the y value, 53. So I'm almost done. This is great. I have a great way to model this behavior. My equation would be if I clean it all the way up, so distributing that negative 1.75 and adding the 53, I'm going to do that on my calculator. And I come up with y equals negative 1.7x plus 63.5. So any scientist could model the temperature of this substance using that equation. That's great. Now the second part of the question asks me find the temperature of this substance after 9.25 hours. Well, hours is my x. Y equals negative 1.75 times whatever the number of hours is, in this case 9.25, plus 63.5. I'll do that again on my calculator, and I end up with 47.3125 degrees after 9.25 hours. All right, so again, take away from this little video, that important formula. I'm going to put on this next slide 4 problems, give them a try. All right, and I'll talk to you later. So try these 4 problems, hit pause now, you can keep them on the screen, and then we'll check back with them tomorrow. Bye-bye. And just as a note, 3 of these will come out with nice, neat numbers. Nice and easy, nice and easy, nice and easy. Number 3 will come out with a fraction or decimal of a y-intercept. All right, thanks, guys.